All right. Good day. My name's Patrick Connolly,
Alexis Cooper.
and we're here to present our project. Go
Yeah.
ahead, Alexis.
Our goal for this project was to create a bot um, and the services to support it that allow users to play D&D entirely within Discord. So then that involves all the core game functions, retrieving, storing, updating character information, dice rolls, and all of the logic that goes into them, and modifiers and stuff. And we wanted to do all of that as simply and transparently for the players as possible. And we also had to do that using scalable technologies, Docker for the containers for the different workers that do these things, and Kubernetes cluster to allow us to scale it and work across multiple workers. And then finally, we also had to gather a whole bunch of data and sort of parse it and transpose it into a workable database format in accordance with sort of the rules for the game so that we could add all this stuff.
And kind
So
of in
that,
addition to what you're saying there, Alexis, we had some other challenges too. We had to implement some additional technologies that we didn't necessarily expect to do so at the beginning of our design phase. So as we learned and as we built things like TLS. We did that regex parsing that Alexis mentioned. We looked at asynchronous message queuing so we could continually forward messages and looked at relaying error messages all the way back to the client so we could actually support our own debugging. We implemented most of the features that we planned to implement. And jumping down from there, looking at hardware and software, we used a good number of the things that Alexis mentioned. Some built-in Python libraries, used Cassandra database so we could try and learn a new database technology, and many other things so that we could build a base service and make it scalable and auto scale under stress. So this was the basic architecture that we used, all of the different components, looking at gRPC, RabbitMQ, and a bunch of different worker threads that we custom coded in accordance with D&D rules. So we could relay messages from Discord into our ingress over to the gRPC that would feed it to the appropriate worker, interact with the appropriate database component, and forward any necessary responses going back to our Discord client. So with that, I want to transition back to you, Alexis. You can actually talk about some of those commands, and I'll go ahead and bring up Discord on screen.
yep. So we had to first of all implement a parser to actually parse all the commands so that we could get it into a protobuf with a pretty standardized design. So let's just show some of those. So just go character get all. And so here's the character that I already built. You can see I've got my stats here, I've got my name, race, etc. Um, and so let's just demonstrate a roll as well. So you can roll raw dice. Look at that, not 20. Um,
Feels good.
Feels great. And so let's also, but we also implemented rolling for checks and attacks. And so say I want to roll attack for a heavy crossbow. Well, I don't have a heavy crossbow equipped. So let's just go and, oh God, sorry, I copied something and it didn't paste properly.
Things
Let's
happen.
just equip that. Just equip heavy crossbow. Things also happen. Sometimes there's some bugs, but still went to the
This looks like it still went through and probably have some server-side error handling that needs to be corrected.
yep. And so now we can roll attack, and there we go. It calculated all of the stuff with the how much damage it does. Well, it didn't do that, but what the attack bonuses are, and so. So that's a demonstration of how it works, and I'll pass it back to Patrick now for.
Yeah, yeah. We'll walk through a couple other pieces here. So we've demonstrated that minus a couple of minor bugs, we're still getting those error messages back and continuing to develop this, improve upon it. And also want to talk about going beyond the architecture, where and how we actually went through everything to what's it called? To actually assess the performance. right? And in that, what we did is we wrote a couple of scripts to rapid fire send about 50,000 commands to our service architecture. And roughly that took about 10 minutes. And during that time, we worked to capture metrics on the number of pods that we had, on the average response time that our client took to actually get something back, and several other metrics here. And Alexis was kind enough to actually put together the visuals and explain out, like, hey, just generally speaking, with two different workers running at the same time, we have a stress test for our character service and a stress test for our role service. And they have similar curve shapes. And with that, just the mean response, or median, I guess in this case, response time is about 0.025 seconds. So if we're doing these simultaneously, it's really about just a little over a tenth of a second per command, which is maybe not amazing, but I would say for an initial deployment and initial capability, pretty good. And I think what is really important there is that it's centered so at that low point because we were able to figure out the right ways of scaling the service architecture. And you can see that as you're looking at some of these plots down here, increasing the number of message query services or the number of workers that we have in different categories based off of their workload. We're able to increase that service architecture to meet the demand and not overuse the resources that we had available to us. And there are definitely some things that we could improve upon in the future. I think that on the database side, since we did Cassandra and we try to treat it like SQL, and it's a very different database architecture. So that's something that we would look at in the future is either modifying our structure in the tables itself so we can do fewer queries, or doing a different database management system to actually make this thing more effective at what it is that we're trying to accomplish. And then scrolling down from there, we also didn't necessarily meet all of the goals of our implementation, but we did get a lot done, and we're pretty proud of that work, especially with the scaling, the parsing, not only of the D&D data, but designing a functional parser to get commands out of Discord and relaying all of that data between cloud native architecture and a completely separate application in a way that makes sense to users. So going further into the future, being able to distribute this across a multiple region or zonal deployment in the cloud, working on that database architecture and further refining some of the bugs that we identified, and some of the performance issues that we saw. We think that this could be a scalable service. Like in my personal opinion, I think this could be scaled into an actual business, like Roll20 or something else of that nature. Because I know people like to play together, but not all the time can you play together. So having a meeting room, as it were, like in Discord, could actually be a fantastic opportunity to do some great work. Alexis, did you have anything to add?
No, I mean, I think that pretty much covers it. There were some, bot features that we didn't actually get around to implementing. I think, we didn't have time to get the lookup sorted. Um, it would also be nice to sort of auto-populate sort of character sheets in the database for that kind of thing after initializing. But in general, I mean, we got pretty much everything that we wanted to scope for this project out of it.
Yeah. And I know I appreciate working with you on this, Alexis.
Yeah, this was great.
But this is our presentation. Hope you've enjoyed viewing with us today, and you all have a great one. Take it easy.